Welcome to MyESAT's SAT Essentials video series. This is a 10-hour video, personally paced SAT program that's designed to provide quality SAT preparation to all students. The series is split evenly between the three sections of the SAT: math, writing, and critical reading. The lectures cover effective SAT test-taking strategies, review frequently tested topics, and provide practice problems that familiarize and prepare students for the real exam. The SAT Essentials video course is the foundation for all MyESAT courses and is used in conjunction with live MyESAT workshops. At MyESAT, our mission is to pave the way for brighter futures empowered by education for all students.
Oh, hello. Nice to see you again. I was locked out of my locker. Wasn't trying to break into anyone else's locker at all. Anyways, my name is Ryan Sulak. Glad to see you. I'm your math instructor for the SAT Essentials video series. Now, welcome to your third and final math class. Yeah, that means in approximately 1 hour, in just 1 hour, you will have completed the basics of the SAT math section. Wow, I wish I had pyrotechnics. And that's an awesome first step to ensuring you do your best on the standardized test. Now, as you are sitting in front of the screen right now, I would imagine that you probably are not feeling emotions of extreme excitement like I am as you prepare for what is probably not one of the most straightforward, low-stress tests of your life. If you've told me those things were true, I would probably suggest you schedule a psychiatrist appointment because that would mean you must enjoy pain. Hey, whatever you're into, but listen. I guess my point is, what I'm trying to say is you probably don't want to be here, right? Studying for this exam, and I get it, which is why we try to make it as interesting and as engaging as possible. But please, when you start feeling frustrated, keep in mind what the SATs really mean. Super awesome test. SAT. Get it? It's awesome and it's a test. Anyways, practicing might suck, but at the same time, you're here because it's such an important part of college admission. The SATs, or super awesome tests, are one of the gateways to a great college, which opens a door for so many awesome careers and other awesome things you guys are going to do with your life. So let's get through this. Together we'll drop kick this math section like it ain't no thing. And as you work your way through this video, try to keep up with me. I'm fast, like a ninja or a mongoose. I need you to actively participate by working through the class problems with us and jotting down key notes like you've been doing this whole time. You in the back, you're starting to get better. I see you. You're making progress. That means you will need to arm yourself with a trusty notebook and a pencil. So if you don't have them in front of you right now, just pause this lecture and go grab them. You ready? Okay, drum roll please. It's go time.
Today's lecture is going to be all about geometry. Get this, about 30% of the questions on the math section will be geometry ones. That's like 1 in 3 almost. It also means that out of 800 points in the math section, about 270 points will be about geometry. So today, let's make sure those 270 points are yours to get. The number one type of geometry questions tested relates to triangles. To answer these questions correctly, you need to know several important laws about triangles that all triangles obey. The first law I want to go over is the law of 180. This is just one of the rules that govern all triangles' lives, or else they get expelled and aren't allowed to be called a triangle anymore. All triangles have angles that add up to 180 degrees. So in our diagram below, angle x plus y plus z equals 180 degrees. But you already knew that, right? How about this one? Triangles also obey the law of proportions. This law says that the longest side of a triangle is opposite the largest angle in the triangle. So, in our diagram, side Z is the longest side because it is opposite angle B, which has to be the largest angle. This has to always be true. And the opposite has to always be true. The shortest side is opposite the smallest angle. So that means side Y, which is the smaller side, is opposite to angle A, which must be the smallest angle. So that sounds straightforward, right? Okay, so let me ask you a question now. What if you have a triangle like where two of its angles are equal to each other? Do the opposite sides have to be equal too? The answer is yes, they absolutely do. So lines JK and lines KL are equal in length. This is an important fact that is going to help you on several SAT math questions. So remember it. It will be tested. Now let's talk about our trusty Pythagorean's theorem. Every high school student knows about this one. This theorem only relates to right triangles though, remember. Pythagoras discovered that if you square the length of the two shorter sides of a right triangle, it will always equal the square of the length of the longer side. So what does that mean? If you know any two sides of a right triangle, you can find the length of the third using this theorem.
This is a cool theorem, so make sure you memorize it. However, it also takes kind of a long time to calculate, right? And you don't have that much time. So here's a shortcut I recommend. The SATs are going to test the same simple right triangle lengths over and over and over again. So instead of using a Pythagorean theorem every time, you should memorize the key triangle lengths that are going to repeat over and over again. This is a great way to save time.
So, let's cover some popular right triangles that appear frequently on the SATs. Write this down right now. You want to memorize this side length set. 3, 4, 5, and 5, 12, 13. Right angles with these sides are very, very common on the SAT. Also, be on the lookout for multiples of these sets. Now, those are just the same sets in disguise. So, for example, 3, 4, 5 is one of our key sets, right? Well, so is 6, 8, 10, and 9, 12, 15. See? It's the same thing, but in disguise.
Piece of cake, right? I want you to instantly recognize these sets. So, like for example, if I said to you, hey, what do you think of when I say 3, 4, blank? You should just jump up and say 5. And that's when you give me a high five and I give you a high five and people start taking pictures and we become celebrities because you understand what I'm talking about. So can you do that? Awesome. I'm counting on it. Get it? Counting on it? Because 3, 4, 5... counting? That was a math joke.
Now, let's talk about similar triangles. Aren't all these triangles similar? They all have pointy sides and kind of look the same, right? Well, don't be racist. Not all triangles are the same. So what makes two triangles technically similar? Well, there are two conditions. One, the three angles in the two triangles are exactly the same. And the second condition is the lengths of the sides of the two triangles are in proportion. Basically what this means is that the triangles are similar if they are basically the same triangle, except one is zoomed bigger than the other. Now let's talk about the law of triangle inequality. This law states that the sum of the lengths of any two sides of a triangle is greater than the length of a third side. The best way to understand why this is true is to imagine, what if the length of two sides of the triangle were to equal the length of the third side of the triangle? You'd just get two lines. If side x and side y were to add to the exact same length as side z,
then the triangle would have no height. It would just be a flat line. So that would not work because that would not be considered a triangle and it would be expelled from Triangle Land. Well, now that we've covered all the laws that the triangles obey, let's practice the most important thing. Let's see how these laws apply to real SAT questions. I'm going to give you a chance to test your skills against 2 SAT triangle questions. You now have 1 minute to complete the problem. Drop kick it, yo! The law of 180 states that the sum of the angles of any triangle is equal to 180 degrees. So, looking at our first triangle on the left, I know that angles x plus y plus z is going to equal 180 degrees. Next, let's look at the right triangle. Since it is a right triangle, and we know this because of that little box symbol on the bottom left, we know that v plus w plus 90 is equal to 180. That means that v plus w is then equal to 90. This problem is asking us to find the average of all these angles, so we do not need to find the individual value of the angles. Just add them all up and divide by 5, since there are 5 angles total. So 180 plus 90 divided by 5 is equal to 54 degrees. Making E the correct answer. Cool? Okay, let's move on to question number 2. This one's a little trickier. Okay, team, time is up. How'd you do? Did you rule that question or did it rule you? Remember, all the questions in this video series are medium level, so don't worry if you think they're too hard for you right now or too easy for you right now, because we will practice questions that are perfectly suited for your level in all of our live workshops. In any case, let's go over the answers together now. Okay, so you have a square inscribed inside another square. How do you figure out the area of the inside square?
Well, if you notice, the inside square sides actually form triangles with the outside square. And not just normal triangles, but right triangles. That means we can use Pythagorean's theorem to figure out the length of the side of the square. Yes! You can see that one side equals 2, making the other side equal 6 minus 2, or 4. Plug that into our equation as a and b to get 2 squared plus 4 squared equals c squared. 20 equals c squared, so c must equal the square root of 20. So you get the length of one side of the square. It's the square root of 20. To find the area of the square, simply square it to get 20 for the area of the shaded portion. 20 is correct. Okay, we're back. Let's talk about polygons. A polygon is a closed geometric figure made up of line segments. Basically, any shape is a type of polygon, including triangles. Polygons are named according to the number of sides they have. You pretty much only need to know one thing about polygons, and that's how to find the sum of their interior angles. For example, do you know what the sum of the angles of a hexagon are? Well, here's how you find out. The sum of the interior angles of a polygon with n sides is n minus 2 times 180 degrees. See the chart below for the list. But don't memorize it, just memorize this formula. Let's do a practice problem now. You have 1 minute to complete it. Alright, so this problem is not too difficult as long as you remember the sum of the angles formula. To find the sum of the angles of an octagon, plug in 8 for n into the equation. Great! The sum of the angles of an octagon is a total of 1080 degrees. Now we're given a ratio of all the angles, so to figure out what the smallest angle measure, multiply each ratio by x, add them all together, set them equal to 1080, and solve for x. Do the math, and it looks like x equals 45. And since the smallest angle ratio was 1x, 45 is the smallest angle, making D the correct answer. Now let's try another polygon question. Once again, 1 minute and 30 seconds. Alright, the easiest way to solve this problem is to just draw it out. Draw a hexagon and connect the diagonals to one vertex and see how many triangles can be formed. It looks like 4 triangles are formed. A is correct. Okay, focus. Now that we've already covered many figures with many sides, let's talk about one that has no sides. Knock knock. Who's there? Yes, it's circles. A circle is a figure that consists of all the points that are the same distance from one fixed point, called the center or origin. That distance is called the radius of the circle, like segment OB or OD. The diameter is a line that passes through the center, and an endpoint is on the circle, like EB. The diameter is obviously then twice the length of the radius. You will need to know the formula for finding the area and circumference. Hopefully, this will just be review for you. To find the circumference or the length of the distance around the circle, use the formula for circumference. Circumference equals 2 pi r. R stands for radius. The formula for the area is area equals pi r squared. Now let's move to circle property 1. Remember how triangles have a bunch of laws that they have to obey to live in triangle land? Well, circle land is the exact same. Circles have their own sets of laws. The first one we're going to cover now is the sum of the interior angle of a circle equally 360 degrees, right? Then there is circle property 2. The second property is a little trickier. This property says that any line tangent, or touching the circle at one point, then is perpendicular to the radius drawn at that point of contact. So a line like the one on the board is perpendicular, or at a 90-degree angle from radius OP. That's all that means. Great, let's try a couple SAT problems involving circles and see if you can conquer them. You will have 1 minute for the first one. Okay, let's start off by using circle property 1. We know that the sum of the entire angle is 360 degrees. If you cut out a wedge that forms a 60-degree angle in the wedge, then if we find the ratio of that degree to 360 degrees, the total, we'll be able to find out what ratio of the weight was lost. So set up a ratio of 60 to 360. Multiply that by the original weight of the disc, 2.5 grams. And we get the wedge weighs 0.417. Well, we can't stop there. Remember, we're trying to find out the weight of the remaining disc. So subtract 0.417 from 2.5 to get 1.04 grams. And that makes 1.04 our correct answer. That's what you would bubble into your grid. Time for question 2. Who's excited? You'll have 1 minute to complete it. To find the radius of the larger circle, we're going to have to take the information given to us and work backwards. We know that the area of the shaded area is 45 pi. So let's write down what we know about this larger circle. It's the small circle plus the shaded area, which is 45 pi. And the radius of the smaller circle is 6. Now, let's use the area formula to find the area of the small circle. We've already established the radius of the small circle is 6, so let's plug it into our formula. Then, plug 6 squared pi back into our original equation to get the large circle equals 6 squared pi plus 45 pi. Solve that out to get the large circle equals 81 pi. Okay, great. Now that we know the area of the large circle, all we have to do is plug that into our area formula to find r, the radius. And we get that r is equal to 9.
Wow, we covered a lot of information today. Now it's time to see how much you've actually learned. Hopefully something. We're going to do 4 practice problems in a row. You'll have 1 minute each to do them, and I want you to do them one right after another, and I'll show you the answers at the end. Are you ready? Let's start.
Tickety, time's up, folks. Let's go over question 1. If AB equals BC and line BD bisects line AC in the figure above, which of the following cannot be concluded? Alright, so the problem is initially telling us two things about triangle ABC. First, that AB equals BC. That means that we have an isosceles triangle. Yes! Think back to our law of proportions. What does that tell us about the two opposite angles? Do they have to equal each other, or is one larger than the other? No, they have to equal each other. That's what the law of proportions tells us. When two sides are equal in length, then the opposite angles are equal in measure. So W equals Z. Let's mark that on our diagram. Then second, the problem tells us that BD bisects AC. And what does bisects mean? It means divided exactly in half. So then AD is equal to DC. Let's mark that accordingly. Okay, so now let's look at our answer choices and eliminate the one that cannot be concluded from what we know. Answer choice A, Z equals Y, can that be concluded from the information given? If Z were equal to Y, that would mean that BD is equal to DC. And we haven't been given any indication that that is the case. So let's leave answer choice A as a potential candidate. Now let's move on to answer choice B, W equals Z. Well, remember, we already concluded that that is true and marked it in our diagram. Duh. So that means that we can eliminate answer choice B since W equals Z can be concluded. Now C says X equals Y. Let's take a look at our diagram. X and Y are opposite, AD and DC, which are equal to each other. So we know through the law of proportions that then X must equal Y. So eliminate answer choice C. Get it out of here. D says AD equals DC. That's already marked on our diagram, so cross that off. Lastly, BD is perpendicular to AC. How do we know if this is true or not? If you look at our picture, you kind of see that BD looks perpendicular to AC. But how do we know for sure? Well, X equals Y and W equals Z. So that must mean that the remaining two angles equal each other as well. Since they form a straight line, they must both be 90 degrees, making line BD definitely perpendicular to AC. But even if you can't reason that out, notice that this picture doesn't have a note underneath that says, diagram not drawn to scale, so you can reliably trust that if BD looks perpendicular to AC, then it is. So eliminate answer choice E, leaving us with the only answer choice that we could not conclude from the information given to us. Answer choice A. Now question 2. Alright, to find the area of the shaded portion, let's find the area of the entire inscribed circle first. We know that the circle is inscribed in a square with a side length of 4. So then you know that the diameter of the inscribed circle must be 4 as well, making the radius 2. Perfecto! Now we can plug that into our area formula to find the area of the circle. Remember, area equals pi r squared, so plug 2 in for r to get pi times 2 squared, which equals 4 pi. 4 pi. Now, to find the area of just the shaded portion, it's just 3/4 of the total area. We know this because the white triangle is 1/4 of the area of the square. So multiply 4 pi by 3/4, and the 4's cancel each other out, and you get 3 pi. Not as good as 4 pi. Look through the answer choices and aha! The answer choice is E, our correct answer. Moving on to question 3. Two sides of a triangle each have length 5. All of the following could be the length of the third side except... This question asks us to draw upon our triangle inequality knowledge. The triangle inequality law says that the length of any side of a triangle must be less than the sum of the two other sides, or x plus y is greater than z. So, if we're told that this triangle has two side lengths of 5, then the third side must be smaller than 5 plus 5, which is 10. So z is less than 10. So of all the answer choices, the only answer that could not be the length of a third side is what? It's E, 10. Remember that the third side cannot equal the sum of the other two. It has to be less than the sum of the other two sides. So answer choice E is correct. Last but not least, question 4. In the xy coordinate plane, what is the area of the square with opposite vertices at -2, -2, and 1, 1? Let's quickly sketch this so we have an idea of what we're working with here. So it might look something like this. Area of a square is length times width. To find the width of a square, let's subtract the x-coordinates. So 1 minus -2 gives us +3. Well, since it's a square, we know that the length is also 3. So using the area formula, 3 times 3 equals 9, making answer choice B correct.
Alright guys, remember to do your homework. After watching the first lecture for all 3 sections, take the SAT practice test number 4 from the official SAT study guide by College Board. Schedule your workshop today at www.myesat.com. Alright now, it's the moment you've all been dreading, or waiting for. Depends how much you like this tutorial video, but I'm sure you love it, so you're dreading it, I hate it, but we're coming to a close. This is the end of the math tutorial series of this video, and I know it's sad, but hey, we gotta go at some point, right? I'll still be here for you. Jake will still be here for you. If you guys want to come chat with us again, and by chat I mean watching the screen, then turn on the video and come review these concepts that we went over together. You can watch them at any time. It's an excellent, free, easily available resource for you. And just because we're done with the video series doesn't mean the party's got to stop, you know what I'm saying? We'll practice the strategies in this series and cover many more in our live workshops. So you can select and reschedule your workshops at myesat.com to target your personal needs and fit your unique schedule. But until then, hasta la vista, baby.